Hello everyone, my name is James Stigall. I'm a doctoral candidate in computer science at Bowie State University, and I will be presenting a paper that I co-wrote with Dr. Shiraj Sharma and Sri Teja Bodhampudi entitled Situational Awareness-Based Augmented Reality Instructional Module for Building Evacuation. Situational awareness is the awareness of 3D spaces around you. Both the first responders and building occupants, the evacuees, must have a sense of situational awareness. However, visualizing 3D spaces can be difficult, especially in situations involving low visibility, such as heavy smoke. To overcome this challenge, we built an augmented reality instructional module to help people evacuate a building during an emergency. 3 different versions of an ARI module were built, each with its own set of unique features. User studies were conducted to evaluate the ARI module. However, more studies are needed to validate its usability, ease of use, and its feasibility as an evacuation assistance tool. The system architecture for version 1 considers the mobile device and the module and the interaction between the module and the mobile device. The user carries a mobile device with a module installed on it. When the user encounters an AR marker associated with the module, a floor plan is generated on the display of the device. To the left of the floor plan, there are toggle buttons that the user may use to show and hide the visual cues on the floor plan, as well as virtual fire and smoke, and as well as developer information. 2 devices were used to test out version 1. As far as versions 2 and 3 are concerned, the user navigates to the exit all the while using the posted signboards as markers. Whenever the user encounters one of these signboards, the user points the device towards these signboards, and a floor plan is generated on the display of the device. The user from there can toggle on and off different layers to add more contextualized information onto the floor plan. The devices used to test out versions 2 and 3 were the Samsung Galaxy Tab S5e, the Samsung Galaxy Note 9 and S9. In phase 1, the floor plans were drawn using SketchUp. The floor plans were based on that of the computer science building at Bowie State University. The module will be modified to include floor plans such that it can help users evacuate any building in general. But as a prototypical example, the computer science building was used in this project. Objects such as tables, desks, boards, and chairs were added onto the floor plans for realism, as well as textures and other objects. In phase 2, the floor plans were imported into Unity, where they were situated on top of the markers, so that whenever the module detects one of the markers, a floor plan is generated. Marker detection capabilities were realized through the Vuforia AR toolkit. The markers shown here on the right were uploaded onto Vuforia so that when the module detects any one of them, the appropriate floor plan can be shown. In the third phase, key features were added onto the versions, on each version of the ARI module. For version 1, visual cues known as intelligence signs were added. Intelligent signs are visual cues that help users know where the exits are in the building and how to get to each and every exit. The intelligent signs shown in version 1 were blue arrows, moving green doors, blinking exit signs, and picture hints. The intelligent signs were incorporated onto each floor plan so that they would show up on the floor plans, as well as avatars and virtual fire and smoke. For version 2, the floor plans were oriented in the center of the display. There are 3 buttons that were implemented for version 2. One button to show and hide the green arrows, indicating how to get to the exit. A second button to show and hide virtual fire, and a third button to show and hide developer information. In version 3, a pinch gesture was implemented so that the user can zoom in and out of the floor plan as desired. Also, a color ladder was implemented to differentiate each room on the floor plans. A user study was performed to evaluate the version 1 of the ARI module. The user study, the questionnaire for the user study included questions based on the system usability scale and the technology acceptance model. The technology acceptance model, also known as the TAM, addresses 2 aspects of a given system: the system's usefulness and its ease of use. The system usability scale, or the SUS, simply addresses the system's usability. Version 1 of the module was evaluated in a user study featuring participants of different ages and backgrounds. They were first shown how to use the module, and then they try to use the module by themselves. Participants used version 1 of the module first on the tablet and then on the mobile phone. Upon using the module, each participant took a questionnaire based on the SUS and the TAM framework. The SUS scores for each question based on the SUS were averaged. The average SUS score was calculated to be 65.61594, which means version 1 is acceptable in terms of usability. The questions based on the TAM were also averaged, and their averages ranged somewhere in between 2.6 and 2.9, which suggests that the version 1 of the module was somewhat likely to be useful and easy to use. Version 3 of the module was also evaluated in a separate and limited user study. Similar to that of version 1, the participants were first shown how to use the module, and then they used it themselves. After that, they completed a questionnaire about their overall experience with version 3. The results revealed that the participants prefer to use version 3 of the module on the HoloLens. It also demonstrated that version 3 was useful in helping users evacuate buildings with complex designs. In conclusion, 3 versions of an ARI module were built to help people evacuate a building in an emergency. Version 1 was built solely for Android devices, while versions 2 and 3. The version 1 of the module was evaluated in a user study with 69 participants. The user study for version 1 revealed that version 1 was usable and was effective at helping users evacuate a building. Version 3 of the module was also evaluated in a user study, which was limited in scope. The results of that study demonstrate that version 3 was useful in assisting users in evacuating a building. I want to thank you all for listening to my presentation. Take this time, please, to ask any questions that you may have and address any comments and concerns. Again, thank you.